Everyone. Hey, I just wanted to create a comprehensive video about how to write a science lab report. Now, this semester, we spent a lot of time writing and conducting these labs for kind of the physics portion of our semester. And a lot of these labs have been summative, and I know some of you guys have needed a little bit of support to kind of make these up if you haven't turned them in already. So I just wanted to create a whole video just breaking down every single part of how to do this. I also created this guide here, how to write a science lab report. I'm going to put the link in the description below. You can also find this guide in your Canvas resources section. All right, so I broke it down with a little table of contents here, but we're just going to go through and just figure out step by step what we're supposed to do with writing a lab report. All right, so first things first, we're just going to walk through a little example. Now, you remember all the labs that we've done, you guys can find within the modules of Canvas. So, for example, this semester we started with a inquiry unit. We did a pendulum lab, we did a ball on the floor lab. When you guys opened up these assignments, you'll see that you had access to the lab template. You had a Microsoft Word version, you also had a Google Doc version. So say I had opened up one of our versions. Our lab report will just kind of follow this template. It doesn't matter which lab it is, and it doesn't matter if you're in the advanced class, regular physical science class, or physics class. All our templates kind of follow the same order. All right, we always start with the title. What is the experiment? Who's it performed by? Some of you guys are forgetting to kind of write your names in, so make sure you do. We always start with a wild guess question. So it really depends on what it is that we're studying. For the ball on the floor experiment, we were studying the behavior of a ball just rolling across the flat ground. Now, our wild guess question was, what distance will this ball, right, kind of depending on what type of ball you're using, in this case a bowling ball, how far will it roll in 6 seconds? Now, you want to be able to give kind of a wild guess answer. Again, right now, this is really just an educated guess. It will be hard to kind of determine what the real answer is. We just want to have kind of a guess question that at the end of this lab, when you guys make a prediction for that same question, you can kind of compare your two answers. Your answer that had no data, and then your data-informed answer and prediction. Every lab we do always starts with a research question, right? So how does the independent variable affect the dependent variable? Again, your independent and dependent variable will change depending on what the system is that we're studying. In this case, for the ball on the floor lab, we would be studying the time, right? How long it takes the ball to move versus the distance that it's traveled. Again, different labs, different things. In the pendulum lab, we're looking at how does the angle of the pendulum affect the amount of time it takes to do one swing. In our elastic spring experiment in our physics class, we were looking at how does the distance the spring stretches affect the elastic energy that's stored within. In our physical science classes, we did an acceleration lab with a ball going down a ramp. Right, we're looking at kind of in the same way, how does the time that the ball is traveling affect the distances traveled? So our next step is creating a hypothesis. Now, we do our hypothesis in two different forms. We have a graph form and also in words. Now, for the graph form, our goal is to just kind of sketch out what type of pattern do we think we'll get between our independent variable and our dependent variable, right? So if you remember our patterns, going back to our guide here, patterns in physics, we had a horizontal line pattern, proportional, linear, same as proportional, just has a y-intercept, quadratic, or inverse. So in our hypothesis, right, we are drawing out what do we think the pattern will look like. Now, if you're in Google Docs, all you need to do to kind of draw it out is double click on the image. I'll open up as a drawing. We can just click on our line and sketch it out here. If you're in Microsoft Word, what you would do instead is you would go to Insert. In here, there would be an option for shapes. When you click on that, there will be an option to click on a line here, and then you can just draw the line directly on the page. Okay, in words, right, our hypothesis in a graph should match our hypothesis in words. So you would say the relationship between, in this case, time and distance would be horizontal, right? If you drew a horizontal line. The relationship between time and distance would be proportional, right? If you drew a proportional line, etc. So again, you just want to make sure that you are clearly defining what your hypothesis is in words. What type of relationship are we going to get? If you really want to take that next step, you can then explain why you think it would be horizontal or proportional or linear or quadratic or inverse. All right. At this point, this is where we would actually conduct our experiment. Right, each different lab has a kind of data section where if you click on it, it will open up a data page where you can input your data from your lab. Usually in each of the labs that we've done, we've taken like 1 to 2 days to actually conduct the lab, collect our data, and put it in there. Once we do that, we take our data table and then we copy and paste it into this blank section. Now, since you're watching this video, chances are you're not able to conduct the lab, right? We already did the lab way back in the past, or you just don't have access, you're absent, school's closed, some other reason. All right, so in our guide, I actually created an example data table that you guys can use for our data. So if you're looking at our guide, right, we go back to the top, you guys will notice towards the bottom, I have some science lab report data sets. So let's say you need to make up the ball on the floor lab. You were not here, you missed it, it's not complete, whatever, right? So you find the lab that you need to complete still. All right, let's click on that. And you notice we have a few things available to us here. We have the link to lab template, right, which is the document that I was just working on here. I have a link to Desmos graph, which we'll look at in a sec. And I also have a set of example data. Now, this is data that we collected in class. This is from another group, but you could feel free to kind of use this data to complete this summative lab report. So at least, even though you're not able to conduct a lab, you're still kind of getting a sense of what this relationship between these variables looks like. All right, so what we're going to do is we need to take this data and we're going to graph it. Right. So see here, normally we would have our data table, we would paste it in here. So actually I can do that as an example right here. So I'm going to take this data set, I'm going to copy it. I'm going to go over data set, I want to make sure I include my data, I'm going to paste it. All right. Will look a little different if you're pasting from a spreadsheet instead of just a picture. And then we want to graph this data. So in all of our labs, there's going to be a link to a specific Desmos template. All right, now Desmos is the area in which we graph our data. So you'll notice it always starts with a data table. So we have our two variables. In this case, you can kind of figure out, right, T is time, right? That's our x-axis. D is distance. That's our y-axis. So we want to take the data that we have in our data template and graph it, or basically fill in that data table and it will graph it for us. Now, an easy way to do this is, you guys may not know, but you can kind of go split screen with your computers. If you take one of your tabs, you pull it over to the side, all right, you'll see, I have to do this twice. It will take up half of your screen. It will give you some options for which other page you want to take up the other half, right? We're going to click there. All right, this way I don't have to kind of go back and forth between two different pages. I can take a look at my data and then just go ahead and start filling it in. Oops, make sure we do this correctly. 5, 5, 5. Okay. I'm just going to combine these again. Okay, so this is the data that I just entered. All right, so we collected data from our lab, we inputted our data into Desmos. Our next step is we want to figure out what is the pattern, right? Are we getting a horizontal pattern? Are we getting a linear pattern? Are we getting a proportional pattern? Or are we getting a quadratic pattern? So what we have here, move my face, is we have several different patterns or formulas for patterns. And notice they all go D equals. Now, D is our y variable. In this case, it's distance. So instead of getting y equals, right, it's taking our y variable, which is distance, and putting that in our formula. And then we have D equals A. A is a number that can change, right? And we can change our A value by clicking on this A slider. And you notice as we start moving this slider, we get all these different colored lines. Our goal is to figure out what is our line of best fit for our data. So we're just going to adjust our A slider until it fits our data, right? So we're trying to look at which of these lines is going to fit our data the best. And if you're having some trouble, you can just do a process elimination. I see this green inverse line is clearly not going to fit my data. So to kind of clear all this confusion up, I can find this green data line, D equals A over T. I know that that is the format of an inverse pattern, which is Y equals A over X. All right, I'm going to get rid of that. So it kind of clears it up a little bit. I see that this purple horizontal line, where it says Y equals A, is also not fitting my data set. So I can go ahead and get rid of that. It's not really between these two, right? I have this red, D equals AT. If I remember from my different patterns, I can go back to my guide here. So if you look at our different patterns, each one has a different format for its formula. Proportional pattern is Y equals AX. In this case, instead of Y, we have D. D equals AT. Again, T is our X variable, it's time. And then we also have our quadratic, Y equals AX squared. Whereas in this case, it is D equals AT squared. All right, now, so as I'm trying to adjust my A slider, I find that this red line pretty much goes through the middle of every single point perfectly. The blue line, our quadratic line, not so much. All right, now, a couple things for me to notice. One, I want to notice what type of pattern did I get? Clearly, I got a proportional pattern, and I know that because of two pieces of evidence. One, the line itself is proportional, right? If we look at all our different patterns, right, it is the proportional one here. Again, remember the main difference between proportional and linear is linear just has a y-intercept, right? So it doesn't start at 0, typically. Another thing I know of y is proportional is looking at the formula, right? We get D equals AT, which follows the same format as y equals AX, right? So two pieces of evidence, just the fact that it looks like a proportional line and the fact that it follows the same formula. Now, in this case, the y, remember, is D for distance. The A value is whatever number we ended up with here. So we got distance equals 1, and then it is multiplied by t, which is time. So if I wanted to write this out, and I actually can do that here, I would have distance equals 1 times time. Now, other groups may have had a different A value, right? They would still have distance equals something times time, but maybe their line was a little steeper, right? So maybe they had distance equals 2 times time. Maybe it was even steeper than that. Distance equals 3.4 times time. Maybe they had a ball that moved slower than yours. Maybe it was distance equals 0.6 times time, right? You'll get the same pattern, but you'll probably get different numbers depending on how you guys set up your lab. All right, so in this case, we got all this. We have our graph. What we want to do with this is we want to make sure that we take a screenshot of this so we have evidence that we can put into our lab report. So if you all remember how to take a screenshot, easiest way, if you've not already done this, we're going to go to the search icon. We're going to go to snip or snipping tool, kind of like scissors. All right, if you click on that, you'll get this little window will pop up. We're going to click on new. And what we want to do is we want to take just a snapshot of our graph. Now, the main thing we want to look at is we want to have our graph. We also want to have our A value and the formula. The data table, we don't really need so much because we already have that, right? So we're going to, you can just copy this. You can also save it. Go into our template here, and we can paste it. All right. So we have our graph, we have our A value, we have our formula, and probably won't have my face in there. All right. Now, final piece is writing our conclusion. And you can see here, we have several different pieces. We have our claim, right? This is our kind of one sentence statement, our evidence for a claim, our mathematical model, our prediction, right? And our prediction is always going to be based on that wild guess question, and then confidence with justification. So this is what I want to spend a little bit of time talking about. And this is where the guide really comes in handy. All right. So let's talk about our lab conclusion requirements. All right, so our claim. Get rid of that. All right, so we have our claim. We want to name our system that's being studied. We want to identify what is our independent variable, what is our dependent variable. We want to describe what's the relationship between those two variables, right? Is it horizontal? Is it proportional? Is it linear, etc.? Now, even though that's 3 different checkboxes, you can achieve all those with just one sentence. We'll talk about some examples in a sec. Evidence, right? Evidence, you can do a couple things, right? You're trying to provide evidence that your data shows a certain pattern, right? It's horizontal, it's linear, etc. So you can take 2 different data points from your data set. And if you remember, we have some patterns that these patterns follow, right? With a proportional pattern, when X doubles, Y doubles, right? So if you can show 2 data points, right? When X goes from 2 to 4, Y also doubles, right? If it's quadratic, we remember that quadratic patterns quadruple, right? So when X goes from 1 to 2, Y goes from 2 to 8, right? Just kind of showing some evidence from there. You can also just indicate the shape of your line of best fit, right? Your line of best fit is evidence. Okay. Number 3, mathematical model with reasoning. Now, this is really the meat of your lab conclusion, right? This is where you're stating what is a mathematical model. Now, a lot of you guys have had some confusion about what a mathematical model is. Our mathematical model is really just a formula with words that represents your line of best fit, right? Your line of best fit is the pattern that your 2 variables represents. Knowing this pattern and knowing this mathematical model allows us to make predictions for the future of what would happen if. All right, so everybody states the mathematical model. with the A value. You remember in our graph here, our A value was 1. Right, so this is our mathematical model for this. Instead of writing just D equals AT, our mathematical model would be distance, right, which is the Y, equals 1, right, we found that here, times time. That is our mathematical model. All right, so I know if I want to know how far our ball went in 1.5 seconds, right, I would do 1 times 1.5. Pretty easy, right? It would go 1.5 meters. If I want to know how far my ball went in 2 seconds, I would just do 1 times 2 seconds, which would be 2, right? The distance would be 2. Kind of see that on our graph here. We would explain what the constant A value represents, right? So our A value is 1 what, right? In this context, we know that 1 means that our ball is moving 1 meter every second, right? It's velocity, right? If we take distance divided by time, our A value is velocity. If it's a horizontal pattern or quadratic pattern, right, our A value will be a little bit different. Explain how the relationship makes sense for observations from the real world, right? You'll want to kind of look at your qualitative data, right? If you remember, your qualitative data is a observation of the lab with words, right? So you guys may kind of remember that if we have a ball just rolling on the floor, especially for the first few seconds, it's really just moving with constant velocity. So we can explain the ball is not speeding up, it's maintaining a constant velocity, so that every second it is going to cover the same amount of distance, right? In 1 second, it will cover 1 meter. In 2 seconds, it will cover 2 meters. In 3 seconds, it will cover 3 meters, etc. And then finally, we can just kind of explain a little bit of the science behind it. Really just kind of depends on what the lab is about. Finally, we can restate the mathematical model using all of our words. Number 4, we make our prediction, right? So this is really kind of bringing back our wild guess question. In this particular lab, our wild guess question was, what distance will this ball travel in 6 seconds? All right, so this is where we want to use our mathematical model. Okay, so we're going to state the value of the independent variable. So in this case, our independent variable is time. So in 6 seconds, we want to predict what the dependent variable will be. So let's use our mathematical model, which, again, we found our mathematical model is distance equals 1 times time. If our independent variable time is going to be 6, then we will get 1 times 6, right? And then what's 1 times 6? Gives us 6, right? So our distance would be 6 meters. That would be our prediction. And in 6 seconds, our ball will travel 6 meters. Now again, if you want to go that next step, which in some of our classes we haven't got to yet, we would also include some uncertainty and units of measurement based on our data collection. Finally, justification, right? We want to really just establish how confident are we in our prediction. So I said in 6 seconds, our ball would travel 6 meters. I will say, am I really confident in that prediction? Am I kind of medium confidence in that prediction? Am I like not confident at all? I just had to give an answer. In order to figure out how confident you are, we want to use our confidence matrix. We have that right here, confidence matrix. So there's kind of 2 things that we're looking at. We want to look at for prediction, how close is our prediction to the data that we collected, right? So I said I want to figure out how far did my ball travel in 6 seconds. I want to find, is 6 seconds within the data that we observed? Is it just slightly past the data we observed, or is it way past? So let's kind of look at our graph. My head. Okay. So you notice with our data set, our times that we recorded was really from 0 to 1. And we want to predict how far to go in 6 seconds. You can see our graph doesn't even go all the way to 6 seconds. I have to zoom out to get to 6 seconds. All right, so all right. So we're trying to figure out how far did our ball travel by this point here. Now, again, is this point close? Is it within our data set? Is it slightly outside or is it way outside? Yeah, if we're looking at it like this, I would probably say that's way outside, right? So our predicted value is far from our data range. So really, my confidence in my prediction is probably going to be either medium, medium low, or extremely low. Next thing we want to look at is we want to look at how well does our line of best fit our data, right? We want to look at, does our best fit line go through pretty near to the center of our points? Is it kind of just near the edges of our points, or is it going to be kind of way off our points? Okay. In our example lab here, I can see that it is pretty much going through nearly the center of all of our points. It's definitely touching all of our points. So it's actually a really good data set because it fits our line of best fit almost perfectly. All right. So I'd say it is the best fit line is near the center of nearly all our data points. All right. Which means it would be our confidence would be high, medium, high, or medium. So really, I want to say, where does this column meet this row? Right. Obviously, they meet at the medium level of confidence. So my confidence in my prediction that the ball will travel 6 meters in 6 seconds, my confidence is medium because the predicted value is far from our data range and the best fit line is near the center of nearly all our data points. All right. So that is our justification. All right. Oops, let me get a little ahead of myself. So finally, we have a research extension question. Again, there's no real wrong answers for this part. This is just based on our system, whether we're rolling a ball, driving a car down a ramp, stretching a spring. We want to just ask, what's one thing we can change about our lab and ask another question about, right? What would be a new variable? What would be, how would changing the mass of our object affect it? Etc. So really just a question that you're curious about that you would want to ask about our system. All right, moving on. If you guys are needing some more support with writing your conclusion, here's just a very basic template that's more or less fill in the blank. Again, it's super general. It's really meant to kind of fit any type of lab we're doing in any class. So it's not perfect, but you can use this to kind of help you out. What's actually going to be more helpful to you is going to be a list of some sentence starters, right? So we have some sentence starters for each section of our lab. So for your claim, right, you're just having trouble figuring out how to start, right? We know you need to describe the system, identify the variables, and state the pattern you found, right? You could say, after analyzing the ball rolling on the floor, I conclude that there is a proportional relationship between time and distance. Boom. Done with your claim. Evidence. Describe the data you have to support your claim. You say the strongest evidence is that the line of best fit is proportional. This claim is supported by this first point. Let's say this first point, 0.23, 0.25, and then 0.51, 0.5. We see when our x variable doubled, our y variable doubled as well. All right, etc. All right, just some sentence starters kind of get you started writing. To give you some examples of some differences between some level 4s, level 3s, level 2s. Again, these are very general. This level 4 would not necessarily be a level 4. Kind of depends on what class you're in, if you're in the advanced or the regular class. But just wanted to give you a little bit of idea of what separates a level 4 from level 3 is not necessarily just like the length of your statement, but the quality of what you're writing. So for example, in your claim, we have 3 different claims, all saying the same thing, but with different levels of quality and information. Right. So for our first statement, after investigating the behavior of the ball on the floor, so we've named our system, I conclude that there is a proportional relationship, right? We named what the relationship is between the time the ball rolls and the distance the ball rolls. So we named our system, we named the relationship between our variables, and we named what the variables are. Now you can see that this is different than our second statement here, which is similar in length, right? This one, it says, after investigating the ball on the floor, so we name the system, I conclude that there's a proportional relationship, name the relationship, between the independent and dependent variables in this lab. Now, the one thing that went wrong with this statement is they did not mention what the independent and dependent variables are. So again, that's kind of a difference between a level 4 response and a level 3 response. Now, finally, this last one, I conclude that there's a proportional relationship between what? What variables? What's the system? Right? It really doesn't tell me anything. So that's just kind of clearly a level 2 response. Again, you'll see kind of the same format for all these rest of the statements. Again, just notice the difference between your level 4 and your level 3 statements. It's not necessarily length. It's more about just the depth and quality of what is written in that statement. And you'll notice they kind of check all those boxes off in the parts of our conclusion. One thing I will kind of go over real quick is the mathematical part with reasoning. This is the part where, again, I'm really spending most of my time reading because this is where a lot of our answers will differ. So as far as level 4 statement, the system of the ball rolling on the floor can be mathematically modeled as distance equals 2.5 meters per second times time. So notice we have our mathematical model is very clearly defined, right? We have our distance, which is our y variable, equals our a value, 2.4, times time, which would be our x horizontal variable. And then we explain it, where the constant 2.4 meters per second is the velocity of the ball, and that means that each second the ball travels 2.4 meters. So we explained what this a value is, what this 2.4 is, right? It's not just a random number that we get. We want to explain what it actually is. And we want to explain why this mathematical model makes sense, because you might get some like crazy number in here if you did something wrong. So you want to be able to explain it. And sometimes if you did something wrong, you got a crazy number and you're trying to explain it, you might figure out, maybe I did go wrong. So this is kind of a good check for you to really understanding the why of what we're doing. You know, it's not about just checking off these boxes. You really want to understand the behavior of our natural world. All right. And then this model on the floor can be generalized by saying that in general, distance equals velocity times time, right? And velocity will be different depending on what the system is, but we can always kind of figure out our distance by multiplying velocity and time. Now, obviously, you'll see kind of the difference between our level 3 response and level 2 response, just way less information, way less depth, right? So you don't have to go crazy to get a level 4. You really just have to like explain the mathematical model and have a working mathematical model. I'm not going to go into the next few steps because those are pretty self-explanatory. All right, so once again, at the end of this, you guys can find a example data set, the link to the data template, and the link to Desmos graph for each of these summative labs that we've done. Again, I kind of broke it down by class, so you're not doing ones that we didn't do in class. So just make sure you guys are reading those carefully. Feel free to use those data sets. I'll post, again, this whole lab report guide in Canvas, and also we'll link it in the description below. If you guys have any questions, please, again, go through this video, go through this guide, and then feel free to email me. But hopefully I'm able to answer a lot of those basic questions about how to write up your lab reports. And don't forget, once you have typed out your lab conclusion, right, all be typed out here, you can just go through this checklist, make sure you checked off all those boxes. Again, there's a confidence matrix here for you to kind of use. Make sure you guys are submitting it through Canvas. All right. Again, if you are not sure which ones you've done, which ones you haven't done, just check Teacher Ease. A couple other things. One, if you do this as a Google Doc, in this top right corner here, you want to make sure that you click share so that I can actually have access to it when you submit your link. Right, you just click on the share button. Really, as soon as you click share, it will automatically pop up as anyone on the internet or anyone with the link can find, and that's all I need. Right, you don't have to like type in my email or anything. You just want to make sure you click the share button at least. All right, and then click done. All right, that's it. Again, right in Canvas, when you go to the specific lab, over here you'll see, submit assignment. Click on submit assignment, and then either upload your document or give me the link to your document. Turn it in, and should be good. I'll go ahead and grade it as soon as I get it, or sometime around. All right, have a good one. Bye.